current across a capacitor and I have to find the voltage. Or I'm given a graph of voltage across an inductor and I have to find the current. If you look at those, what you see is those are integral relations. So the current across an inductor or the voltage across a capacitor comes from an integral. And if you're supposed to be graphing it, that means you're not looking for a single number. If it just says, what is the voltage at time 4, then sure, you just do the integral at, from whatever time to whatever time, and you get a number. But if you're supposed to graph it, then you have to get a function of t to graph it. So let's say that I'm given this graph of current. And it looks like this. Okay, so this is 1, and yes?
We got a caller on the line.
Yeah.
Okay.
Yeah, you're not sharing the screen.
Oh, thank you.
All right, that's been relayed.
That was very important.
Muy important.
I am recording, but I can't get back to my Zoom.
You can press the camera icon right there.
Where is it?
To the top right.
No, that just turns me on. That doesn't.
Mind.
That's just Zoom. That's just my Zoom camera. That's not. No, I got to do this. There we go. Okay. All right. All right. So, and I'm going to say this current is in amps. And time is in seconds. And my capacitor, I'm going to say it's 2 farads. So our equation for voltage is the voltage as a function of time is our voltage at our beginning time plus the integral from our beginning time to t of I of t dt, but we've got a 1 over a capacitance right there that I left out. So in order to do this, we have to know what our function is. Right now I just have a graph. So I need to get what it is as a function. So I of t as a function is 0 for t less than 1. And then for greater than 1, I have to figure out what that is. Well, that's a line. Lines have the formula or the equation mx plus b, where m is the slope and b is the y-intercept. So that is one way to get it. Or you can get 2 points, any way that you know to get an equation of a line, which you all know because you've all had Calc 2 and are now in differential equations. So to get the equation of a line, you just need the slope and the y-intercept. What's the slope of this line?
1.
It's 1. Go up 1 over 1. So t. What would the y-intercept of this line be?
0, 1. No, 0. Is that supposed to be on the origin?
This is supposed to be on the origin. It went up 1 and over 1. So it would go down 1 and over 1. So its y-intercept would be negative 1. Okay, for whatever reason, that seems to be throwing people for a loop. It has the point on it, 1, 0, and the point 2, 2. The slope is 2 minus 0 over 2 minus 1, which is 2 over 1. Wait, 1, 0. Oh, it's got a slope of 2. Okay, now I feel silly. Wait.
Does it?
Yeah, it's going up 2. My graph is bad. Okay, I'm ridiculous. Yes. All right. I went up 2 and over 1. Yes, my graph was very bad. Up 2 and over 1. Yes. So that means my y-intercept is also wrong. So that's why it's throwing people for a loop. Okay, so my slope is 2. And so I would go, if it's not over 1 and down 1, I'd go over 1 and down 2. So it would be minus 2. But just in case, to double check, if you had y equals mx plus b, you plug in y, 2 equals 2 times 2 plus b equals negative 2. Okay, so now I have my function for I. So now I need to get my integral to get what the voltage is. So the integral for 0 is just 0, so that's easy. The integral for this one, from 0 to t, of 2t minus 2, (1 over c) would be t squared minus 2t, not from 0 to t, from 1 to t, and then I plug in t, I get t squared minus 2t minus, and then if I plug in 1 minus 2, t squared minus 2t plus 1. And so my voltage would be 1 over my capacitance, which was 2, times t squared minus 2t plus 1. So that would be my voltage for t greater than 1. The one thing I didn't have to do with this one is to find out what the voltage was at the beginning, because we knew it was 0. So that part was just 0. So that's that one. Let me see. Yes, it was a number 2 on the y-axis. Yes. Other questions? Does it make some sort of sense now?
So for each interval, you go through the equation?
Yes. For each interval, you go through the equation. Not only that, for each interval, you go through the equation, but you also have this pesky little business here in front that you have to figure out what this is. And I avoided that in this problem to make it equal to 0 because I was trying to pretend like it didn't exist because I didn't want to answer questions on it. But now I just gave myself away. So you do have to, if you had it, you would have to figure out what that was. So just to make it easy, if we said here that our capacitor was originally at negative infinity, the voltage was equal to negative 2, then I would have a negative 2 right here, and I would have had to have started this with a negative 2.
That's like,
So for the next interval, it starts at 0?
No, for the next interval, so that is the, especially, so let's say I had this and this and this. When I start this interval right here, so I've already done all my work, and I have my voltage for t less than 1, and I have my voltage for t between 1 and 4. When I start this one, to get V of 4, I have to plug in to this one. That's what I was doing when you asked the first question and everything started to fall apart. So you asked a very good question. I think it was you. But that's the hard part. But you're not going to have one. So, all right. Moving on.
There's a question.
Oh. So V of T0 would either be given or found out through a circuit. Usually it's not found out. It's the first one is given. The next ones you figure out on your own. Let's just say that I have already found, I have my function, I've got my current over here, blah, blah, blah. I have already found that V of T for T less than 0 is T plus 6. And then I have I of T is 4T for T between 0 and 2. Okay, so now I'm doing the 0 to 2 part. So I'm doing the 0 to 2 part, and I need to get V of 0 plus the integral from 0 to T of 4T dt. Where do I get that V of 0? How do I find that?
It's from the last.
From the last one. So this is what the voltage is up until 0. It can't change instantaneously. So at 0, it has to be what this is at 0. So V of 0 would equal, you plug 0 in, you get 6. So then I do 6 plus the integral from 0 to T of 4T dt, and then I'd go on from there. Did that answer the question? Yes, good. Okay, good. All right.